So here we are going to solve the fourth question, which is inverse Laplace transform using the partial fraction. Here also we can observe that the denominator part, the s power, you can observe if we expand this, it will be s cube, which is greater than the numerator power, which is s power 1. So we are going for partial fraction here. So how to split up? This is a repeated linear factor. If you observe, s minus 1 square is basically s minus 1 into s minus 1, right? That is the repeated linear factor. For that purpose, what we can do is that whenever we get in this kind of thing, suppose the numerator divided by s minus a square you're getting. Okay, suppose what will happen to that? It will become a by s minus a plus b by x minus a square. This is how we are going to expand. Now what about s plus 2? So if you want, you can add here x plus 2 minus 2, anyways it's the same thing. Okay, s minus b I'll add here. So what will happen? One more thing will come, which is c by x minus b. That's it. This is just a linear factor. We have studied about linear factor. Just to divide by that linear factor. That's it. No other thing. So only thing is that repeated. You have to remember this part. So we'll simplify now. So this is equal to a divided by s minus 1 plus b divided by s minus 1 square, right? Then plus c divided by s plus 2. This part is done. Now what we have to do? We have to find the values of a, b and c. For finding that, first we have to take the LCM on RHS side. So how to take the LCM? Let us see. 4s plus 5 divided by s minus 1 square into s plus 2 as it is equal to. Now below s, what is the LCM we are getting on denominator? See, denominator, always remember LHS part denominator will be same as what RHS part denominator. Okay, so here s minus 1 is there, s minus square is there, s plus 2 is there, multiply out together, that will be the denominator part of RHS. So here it will be s minus 1 s so what will be the LCM you will be getting here is that s minus 1 square is there, s plus 2 is there. So it will be LCM s minus 1 square into s plus 2 will be the LCM. It will be same as what the LHS LCM. LHS denominator. Okay. Now below a, s minus 1 is sitting. So what else is not there? S minus 1 square and s plus 2. So s plus 2 is not there, and s minus 1, one other factor is also not there. So you have to multiply a with s minus 1 and s plus 2 plus b. Now here already s minus 1 square is there, that means this part is already there. So you have to multiply with just s plus 2 plus c into s plus 2 is sitting already this part, right? So we have to multiply with this one, s minus 1 square. Done. Now how to find? Now we know that LHS part, this part and this part will get cancelled. So what is the remaining thing you are getting? So after getting this part, we are having two methods to find out A, B, C. One method is to use what comparison of coefficients on RHS as well as LHS. Other method is to substitute the value of S, eliminate other variables and find out one variable at a time. That is the method. Okay. Now we'll see what are the factors we have got. For example, if I substitute here, s minus 1 is sitting. Okay. Here also s minus 1 is sitting. Only thing is that here square is there, that doesn't matter. Here multiplication is there, right? Everywhere multiplication. If I substitute s value as 1, what will happen? This will be eliminated. So that means this a part will be 0. SC part also will be 0 because 1 minus 1 is 0, 0 square is 0. This part is 1. Only part remaining will be b. So here LHS also we have to substitute 1. So 4 into 1 plus 5 is equal to b into 1 plus 2, which is equal to b into 3. LHS part we can say 4 plus 5 is 9. So 9 is equal to b into 3. So that implies 3 will go there. B value is equal to 9 by 3, which is 3. Now if you see s plus 2 is sitting here, s plus 2 is sitting. If you substitute there minus 2, what will happen then? If I substitute s is equal to minus 2, right? So what will happen to that? This C part, A part will be gone and B part will be gone, right? Only thing is that C part will be remaining. So LHS side 4 into minus 2 plus 5 is equal to C into minus 2 minus 1 square, which is equal to C into minus 3 square. Minus 3 square we know it is 9, so C into 9. On LHS side we can see it is minus 8 plus 5, right? What is minus 8 plus 5? Which is equal to minus 3. So C into 9. So 9 will go there. So that implies C value will be minus 3 by 9, which is minus 1 by 3. So we got C value also. Now we have to get A value, right? A value. How to get A value? Now we cannot substitute any other thing because already we have substituted 1 and 2. So no other linear factors is left out in order to get A value. Because if you substitute any other thing, A value will be automatically deleted. Now what is the remaining concept we have? Now we can go for what? Comparison the coefficient. Coefficient we can compare it. Or otherwise if you put s is equal to 0 also you can get the value, but still we'll go with what? Comparison, so that you will study one more concept there. Okay, so we'll compare. For comparison, first expand this thing. So 4s plus 5 as it is equal to A into, so we have to expand this entire thing. So it will be s square plus 2s minus s minus 2 plus this will be bs plus 2b, and this will be c into a square, so s square minus 2ab plus b square. So this becomes a s square plus as minus 2a plus bs plus 2b plus c s square minus 2, oh sorry, 2 here, 2 as is there, so 2 cs is there plus c. Okay, now take s square is the highest power, you take common. So what is left out? A is left out, then here also plus c, then you take s common. So what is inside? 2a minus 2c, then you take all constants. For here also b is there, right? So b also you take common, so it will be plus b, then it will be minus 2a plus 2b and plus c is there. So what is then remaining? So s square, see here how to compare the, that is a new concept we are studying. How to compare the coefficient? See here s square is there, here there is no s square. Can you compare? Yes, you can compare. While comparing you should write it as what? Comparison, compare s square coefficient. So comparing s square, on the LHS side it is 0, coefficient is not there means it is 0. 0 is equal to what? Coefficient of s square, which is a plus c. So a plus c is equal to 0. From this can I get the value of a? Yes, you can get. A is equal to what? Minus c. That implies a value will be, c value we know it is minus 1 by 3, so it will become plus 1 by 3. Minus of minus, it is plus. So a value also we got. Now the thing is that this method can be used to find out all the variables. If you don't want to substitute these values and get the answer, you can directly go by expanding this thing and directly compare it, compare s square, s term, constant term with the LHS part, and find the equations first and try to analyze that equations and get the value of ABC. That is also fine. That's why I said this is the second method and this is the first method you are using. This is a less time consuming thing because you have to just substitute the value of that thing and get the value. But it is not other thing. Some of the questions you won't be able to get the answers. Otherwise, so what you should have done for finding a value, you should have substituted s value of 0. You would have got some equation here because we are trying to eliminate one variable on the LHS side. Okay, so if you want to eliminate one variable on LHS side, just substitute 0 here. So phi is equal to, you'll be getting some equation. From in that you substitute b and c value, you'll be getting a value. That is also possible. But since I wanted you to understand the comparing, how to compare the coefficients, that's why I did this part. Okay. So do I have to compare next s coefficient, a constant coefficient? No, because already I got the values, right? A, B, C. So no need to substitute. Now the final thing you have to write. Okay, now what I'll do, I'll write all the values since we have got. So a value we got it as 1 by 3. So 1 by 3 divided by s minus 1, right? Next plus b divided by b value we got it as what, 3. So it is 3 divided by s minus 1 square plus c divided by s plus 2. So c value is minus 1 by 3 divided by s plus 2. Now after writing this, we have to first find what? Laplace inverse. So you have to take Laplace inverse on both sides. So here also Laplace inverse, here also Laplace inverse. Okay, LHS as well as RHS. So LHS, how will you expand this? So this can be written as 1 by 3 is sitting, that you take it outside since it is constant. Laplace inverse of 1 divided by s minus 1 plus 3 is a constant term, you take it outside. Laplace inverse of 1 divided by s minus 1 square plus, here minus 1 by 3 is sitting, so you write it as minus 1 by 3 outside. Laplace inverse of 1 divided by s plus 2. Now which formula we are going to apply? See here, this is of which form? 1 by s minus a form. So we have already studied the formula for that. Laplace inverse of 1 by s minus a. What is the answer for that? E power at. This formula we have studied. So this same thing we have to going to apply here. So it is equal to 1 by 3. Laplace inverse of this thing will be, what is a value here? 1. So it will be e power 1t, or you can simply write e power t plus 3 into. Now here one problem is that since it is not 1 by s minus a, it is 1 by s minus 1 whole square it is there. Now this you have to understand, very important thing. So this will separately solve. So we have to find 3 as it is. Okay. We have to find Laplace inverse of 1 by s minus 1 square. This is basically we are going to apply what? Shifting property. You might have studied that. I have uploaded that videos also, kindly see that. Okay. So here we'll try to understand. So s minus a form, if you are getting the denominator and you don't have the formula, then we have to go for what? Shifting property. How to apply shifting property? S minus a has to be converted into s, but the thing is that you have to multiply with e power at. E power at. Here what is s minus a? S minus 1 is there. We have to shift it to what? S. What is a value? 1. So this will become e power at, which is 1t, which is t, into Laplace inverse of this thing will now change. S minus 1, wherever it is sitting, it has to be changed to what? S. So it will be 1 by s square. Very important. It will become 1 by s square. Okay, this is the important thing you need to understand. Now what is Laplace inverse of 1 by s square? You might have studied this formula, that Laplace inverse of 1 by s power n. What is the formula for that? T power n minus 1 by n minus 1 factorial, right? So here what will happen to this? E power t as it is. Here n value is what? 2. So it will be t power 2 minus 1 is 1, and 2 minus 1, which is factorial. So this factorial is 1 factorial is 1 itself. So e power t into t. So what we will do, we will substitute over there this value e power t into t. E power t into t, right? Minus 1 by 3 as it is. Laplace inverse of this is the, be careful with this one. See, the formula is basically 1 by s minus a, not plus a. So here we are having plus 2. So it should be s minus of minus 2. So the a value is minus 2, not plus 2. So it will be e power minus 2t. This will be the final answer.